Now I'd like to open it up to questions from the audience. Does anyone have a question for our panelists? Go ahead.
Yeah, I'm just wondering, what's the most bizarre insight that your analysis has?
Sure. Yeah, maybe each of you could share an anecdote of the most bizarre insight, a data mining program or statistical insight that was a computer provided to you and everyone was like, what, really? Oh, we didn't know that. And that insight actually had a major effect on your business or changed the way you think about your business or changed the process or product even.
Yeah.
Who would like to go first?
I'll throw one out. Some of the early work we did, we're looking at sort of 300 or 400 different data points, behavioral data points and background data points about students, and trying to understand what's the kind of tapestry of different data points about a student that seems to provide the best prediction of whether that student's likely to be successful or not. There's a tendency to use in education right now much more simplistic sort of single data points, or students showing up to class, for example, or what was their GPA last term, kind of one or two or three things to try to do the same thing that we're using lots of information to try to figure out. So we'd actually identified that there are substantial differences between students' likelihood of successful completion based not just on whether at this one institution they happen to be military or non-military, but literally the branch of service, the intersection of which branch of service they were in, and their engagement and behavior patterns had a fairly dramatic, on a relative scale, impact on their likelihood of being successful, which is something the institution themselves had no visibility of whatsoever. And one of the things that they used this model to make a change on was, they used to literally just create a list of students who had not attended for a certain number of days and then kind of march down that list in alphabetical order or otherwise, and they never quite got to the end of it to try to figure out who was at risk. And what we found was, if you include these other sort of pieces of background information, you find that for some students, missing one day of class was actually a huge risk flag and they were on a bad path. For other students, depending on things like their military status and lots of other background and academic success information about them, they might be able to go 7 or 8 days and still not be at the same level of risk as the other student was after a one-day miss. And so incorporating, I tell educators all the time, I'm not going to come in here and tell you that students with green eyes are dramatically more likely to complete college. Like, it's not going to be something that's just utterly unintuitive and completely unimaginable, but it's really the kind of collection of a variety of little things, none of which individually you would think are very important, that in aggregate can have that sort of 1 day versus 7 day sort of risk impact.
So I can do kind of a macro and a micro example. So from a micro perspective, one of our customers had a perfume line that they were selling and had been selling for years. It was one of their top things. And all of a sudden, the ratings started to crash on it, and they couldn't figure out why. And the consumers, basically the algorithm started to point out the consumers were saying, smells different, something's wrong. Our customer went back into the supply chain. Everything looked fine. Nobody changed anything. And they ended up finding out way up the line, some manufacturer in one of the suppliers' supply chains had changed a small ingredient that ultimately ended up, knocking down the product. And it was something they had so much volume on, it was a significant cash flow issue for them. So they were able to go back and identify that. From a macro perspective, the number of times the words consumers start mentioning price when they write a review for things can give you a perspective of, if we look at it on the scale that we look at it, you can start to see a decline in consumer confidence and the potential onset of a recession. Because you start to see that cycle out early and then you can catch it. So there are a lot of macroeconomic things just given the breadth of data we have. And there's a solid percentage of the GDP that goes through our product in one way or another because people are writing reviews, looking at it, talking about it, et cetera. And you can start to predict macroeconomic trends as well. And some of those have been very interesting as you go back, especially looking at the historical data.
So one of the challenges we always have is outages. That's one of the things we don't want to have happen. And in electric service delivery, ESD, they're responsible for outages. And when I first started with the utility, the head of ESD really didn't care about customers. They were end users, they were ratepayers. It's just people we got electricity to. And I said, if you cared about them, cared about what they thought about you, that's going to impact the way they interact with you. So they measure their outages through a thing called SAIDI and SAFE, which is duration and frequency. And I said, well, let's just start looking at what customers think about these things, how they're perceiving it. And for the most part, what they were measuring in actual outages, we were finding very similar in perceived outages for people who were very satisfied. We also found that the more satisfied a customer was, the greater length of time they would give us to fix an outage. So we could get up to an hour before they'd start to get frustrated. For those that are dissatisfied, they'd give us less than 15 minutes to fix an outage. But one of the biggest changes that came out, so after all this analysis, we kept saying, 78734 is really weird because these people are upset about these outages. They are complaining about them, they're too long, and ESD comes back and says, we've never had an outage in 3.4. And I'm like, well, I'm sorry, but this list of people are saying that you did. Well, we've never had an unexpected outage. We've had planned outages. And I went, okay. I said, but for a customer, an outage is an outage. Well, no, we wouldn't put door hangers on so they'd know it was going to happen. And I said, I bet your door hangers didn't work because they never got the message they were going to have an outage. And so all they experienced was no electricity. And so that they started changing their business model to make sure that they informed customers better when they were actually going to plan an outage.
I would say there's not a real particular story about one, data insight that was miraculous, because if it was, it probably wouldn't persist very long and, in that way. But I think the thing that we always come back to is, again, how I mentioned how easy it is to overfit the data. And, we may have a huge data set and a very small number of, signals or predictors that we're trying to use in order to learn something from a data set. We may follow all the best practices in terms of having in-sample data sets that we're learning on and reserving out-of-sample to test on to see the strength of the prediction and the resilience of the prediction. And, still, different models we use, different machine learning algorithms have an ability to memorize data that it's never seen before in remarkable ways. And there's just, you get tricked. And I think that's sort of the surprising thing that we always keep coming back to, that, you think you follow the best practices and there'll be yet another way that the data will, come out and bite you.
My example is probably a little bit more material science-y and maybe requires a little bit more semiconductor knowledge, but I'll try to go through it as best I can. So one of the major steps that we do a lot of times in semiconductor manufacturing is we call it polishing, where we will over deposit a film like an insulator, and then we'll pattern it and we'll use sandpaper, best example, to polish off the excess. And what we were finding, we had a set of wafers, which is what we call the silicon discs that we build the chips on. We had a set of wafers that were always coming out of the polisher too thin, and our correlation said that they were always coming out of the deposition tool too thick. We're like, well, this doesn't make any sense. Everything goes into the deposition tool, it comes out of the polish tool, the processes are the same, what's going on? And what the correlation actually showed us is that we had a process characteristic that was causing the deposited film to be more porous, and so it polished out faster.